without further ado, I think this is the moment to get started. We've waited long enough, and I've got a lot of questions for you, Alexander. So let's jump into it. As I mentioned before, I'm here with Alexander. He is one of the lead maintainers of Patroni and the other one, which I lovingly call Spicoli, but that's not the name of the operator. It is, what is it? Spilo.
Spilo, yeah. Actually, like probably I should introduce a little bit to the German language. Like basically, Patroni and Spilo, those are Georgian words. Spilo
Mm.
translates to English as elephant. That's very simple and
Ah,
hilarious.
okay.
And
Ah.
unfortunately, like we took this word for like this Docker image, which packages Patroni and Postgres and a lot of useful stuff. But when but before actually Patroni appeared to the world, we are using governor. Like it's a compose governor.
Huh.
It's actually prototype of Patroni. Like and and it wasn't actively maintained, and we decided to fork it. And like I think original code of governor was only something like 400 lines of Python, but like nowadays in Patroni it's very close to 15,000, I think.
Wow.
And after we forked governor, we started looking for a name, and of course I decided to ask our Georgian friend. It was like our former boss at Zalando, and he came up with name Patroni. And Patroni, it's something like Georgian feudal, or like he owns something. Like for example, owns a pet, and in this case, pet is an elephant. So, so
So
basically,
there's the
Patroni
history
is the
lesson.
owner of an elephant.
That's awesome. So so that makes sense because this is a gigantic project, almost like an elephant. And you are Mr. Patroni, the owner of this elephant, in a way. And so let's dive right into it, man. I want to jump into so many different questions. First of all,
Mhm.
we can consider you are, I don't know if you call yourself this, but I think that you're a big fan of Postgres.
Yeah,
And
that's
I
true.
want to know, you're a Postgres fanatic, we could say. I want to know why. What is it about Postgres that attracts you so much?
Well, it's a very advanced open source database. It's like fully free. Like it's not owned by anybody. It's developed by community. So there is not a single company which stands behind. Like there are a few big consulting companies which contribute features. There are a few independent developers who also can do this. Like I really like its freedom, and at the same time, like for example, Postgres allows you to fork it and like let's say to sell your own fork. Of course, like except some big companies, not many people do this. It doesn't make sense. But in general, like if you miss something, for example, like from Postgres, you can easily sometimes not easily of course, but like you can implement this missing feature yourself. You can propose this change to community will review, like provide feedback, and at the end like this feature will be included into the core, like if it is a very useful feature. um,
Hmm.
like that's a lot of freedom about Postgres, and Postgres is very extensible. Like you, like if sometimes you want to have something, like you may not get it into the core Postgres, but you can still implement it as an extension. And on the market, there are a lot of very useful Postgres extensions. Like for example, timescale DB. It's a Postgres extension for working with time series data. Like it allows to efficiently insert this data, store it, and at latest releases there is even some very good compression included into timescale DB, which allows like
Nice.
compressing data like 10 or 20 or sometimes 30 times.
Mm.
So apparently you save a lot of disk space. Uh,
Mm. With that in mind, I mean, obviously, we understand. Big fan of Postgres. Looking comparing with other relational databases, what are things
mhm.
that you think that obviously you've explained some of the advantages regarding freedom, open source, things of that nature.
Yep.
What are some of the other advantages, and maybe what are some of the things that Postgres might be able to learn from some of those other relational databases?
Well, so in Postgres, like from maybe not very like first days, but like definitely for a long time, there is available transactional DDL. Like you can instantly add new column to the table. Like not many like databases can do this because they usually will rewrite the whole table. And good luck adding a new column to 1 terabyte table. Uh, so like it allows to, for example, create indexes without taking heavy locks. Um, and like but like if we talk about disadvantages, like some people don't really like the way how MVCC in Postgres is implemented. Like comparing to Oracle or MySQL, like we don't have undo locks, like only let's say redo write ahead lock, and it means that when you update the tuple, Postgres does not update it in place. It inserts the new version of the tuple. And only afterwards, after vacuum comes and cleans up the space after the dead tuple, and you can uh, you are able to reuse the space. And like as a consequence, you get some bloat on the tables. But the biggest problem that you get some bloat on indexes, and basically indexes are like will never shrink, although in the other databases they're not growing so fast, they're not so prone to bloat. And yeah, so it's there is some work in the community to implement that heap, which basically will do like implement like undo logs for Postgres, and like more or less the same way as other databases are doing it. But it's a very long way, and it take, I don't know, like a few years more
Hmm.
to get it done.
So, like talking about community and what the Postgres community is doing, I know that Zalando is a huge contributor to open source projects, not just the Postgres community projects, but many different ones. So, I wanted to dive into Zalando's theory or their ethos around contributing to these open source projects real fast. And what is it about the Zalando culture that encourages that?
Oh, yeah, it's a tough question. Like in general, we use a lot of open source, like really a lot. Sometimes you find bugs. Sometimes like you want to get some new features into open source. Therefore, you just naturally fork project and like contribute bug fix or contribute new feature. Like, but in some other cases, if you develop the new software, like new library, uh, you can also give it to like outside world that everybody can benefit. And the idea is that like the more user base you have, like the better like testing you get. Like when people use your software, they report bugs, they test it very extensively. uh, you don't always have so much time like for such processes. uh, Basically it's very beneficial to like have some projects in the open, in my opinion. But regarding Zalando, like there is a process nowadays. Like you can't immediately start like a new project in the open. Like you have to grow this project internally. And in case if it makes sense to open source it, it's published um, in the not Zalando repository, but in Zalando incubator. So where
Okay,
it's supposed to grow, like.
nice.
And like in some like we have examples when projects really skyrocketed and got like a few thousand GitHub stars, like got a lot of feedback, get a lot of contributors, but those are not hosted at Zalando. Those are actually regarding machine learning and uh, similar stuff.
Okay.
Like
So,
there is a Zalando research or something like this. I don't remember precisely.
mhm. And were you contributing to the Postgres community before you were working at Zalando, or was that something that came up as you started working there? And for people out there that don't know what Zalando is, it's a gigantic e-commerce store, right? In here in Europe and primarily Germany.
Well, so it's not only Germany; it's basically nearly entire Europe. Like there are not so many countries
Hmm.
where we don't ship stuff. Uh, well, before Zalando, I was contributing to open source, but not so actively, I would say, because like I was always working for very small companies, and you don't have so much time and like for such stuff. Like
Yeah, yeah, for
probably
sure.
one of like not significant, but actually it was very little contribution. It was like to Nginx in 2005, if I remember correctly. Like it was just in the beginning of his journey, Nginx, uh, like web server, and I found one like very little issue, and basically I reported this issue and also thought about fixing it.
And then a star was born, Mr. Patroni.
Not really star. I don't know.
Ah, you're too humble. So let's talk about this Zalando operator and the three that are out there. And can you just give us a breakdown on the differences between the three, when to use one and when to use the other?
Well, so what kind of like are we talking about the Zalando operator or Postgres operators in general? Because
The Zalando operators. I'm thinking specifically about Patroni and Spilo, and then the Postgres operator that Zalando created.
okay, yeah. So basically, it's a classical example of a multi-tier application. Like every layer is responsible for its own job. Patroni is responsible for high availability for Postgres, and like Patroni originally was working only with etcd, like it uses etcd to keep the cluster state, and basically in etcd we keep information which node is running as a leader, as a master. Later we added support of like zookeeper console, and I think 3 years ago or so, like we implemented, like I implemented support of Kubernetes API for leader election. And basically with Patroni, you can deploy Postgres on Kubernetes without any third-party dependencies, without nothing. Like you don't even need to have Spilo, or you don't even need to have Postgres operator for that. You can basically build very slim Docker image with Patroni, Postgres, and you are good to go. It will work. Spilo, it's kind of more advanced topic in terms of Docker images. It packages not only one Postgres and Patroni. We package all supported Postgres versions. It's nowadays starting from 9.5 to 12. Like we did not yet finish the Postgres 13 because some very useful packages are still missing, and on top of that, we also have in Spilo Wally. It's a tool for backup. Like there is also sibling of Wally. It's a Volg. It's basically the re-implementation of the same backup tool in Golang, and it become actually more popular probably than Wally itself. Uh, what else? We also have PGQ and a lot of like very useful extensions like timescale.db, like PostgreSQL, and so on. Uh, Again, like we can deploy highly available Postgres with Spilo, like on a lot of different environments. Like wherever you can start this Docker image, you can get highly available Postgres. Um, and Postgres operator, it solves very high level tasks. Like first of all, we need to orchestrate such deployments. Postgres operator also like helps to manage Postgres configuration or like Spilo configuration, for example, where we want to keep backups in which S3 bucket. What credentials should we use? How often should we push base backup? Something like this. Besides that, Postgres operator is taking care about user management. We have internal user API. Basically, when you deploy the cluster, you specify which team owns the specific cluster. And Postgres operator will call user API. It will get list of users and will create these users in the database.
And just to get to this point, as an organization, company culture wise, how did the decision making process? How did you get to the point where you decided, all right, we need to write an operator, and also the decision why do it as an operator?
Well, so before we started with the operator, we were already running something like 250, very close to 300 Postgres clusters on EC2. Like those were of very different size, starting from like just a few megabytes because people just keep some configuration data in these databases. Some other clusters were already quite big, like 1 terabyte or a few terabytes in size, and of course, there was some difference between production and staging. On staging, in general, you usually don't have so much data, and you don't need maybe so much high availability from staging. Like if for production we normally run 3 nodes, then for staging we can easily run 2. And at some moment we were so overwhelmed with requests of deploying new clusters and or doing some management on existing clusters that we decided, okay, so we need some more automation. And exactly around this time, like first production deployments of Kubernetes happened at Zalando, and we naturally started looking at it because this approach of keeping all what was a good word for that, like you write all your configuration in declarative format, you deploy, and you get everything up and running. The like such.
Yeah. I mean, also just looking historically speaking, just because of spying on you a little bit, looking at some videos on YouTube. In 2018, you mentioned that Zalando had about over 1,000 databases in data centers and ACID cluster in AWS being managed by DBAs and in other Kubernetes clusters. Then in 2019, over 300 databases on premise and over 1,000 clusters in the AWS cloud. Right now, where are you at, and how has that grown? And what do you think is going to happen in the next steps?
Well, so probably I should first finish a little bit with operator. So like we started developing it, and as long as it was in a state that we can migrate staging, that's what we immediately did. Like basically we migrated all staging clusters to Kubernetes, and they were already managed by operator. And like most of incoming requests to deploy some staging, testing, whatever, they were already handled automatically. Like you just deploy CRD manifest and you get your cluster just within 1 minute. That was very handy. And from that moment, like until we actually went to production, it was probably another half a year. And like when we started running like operator in production, the amount of production deployments on Kubernetes was always growing. Nowadays, we have probably more than 800 production clusters on Kubernetes. Like at the same time, on the amount of clusters which we run ourselves on EC2 instances, also with the help of Patroni, is like going down. Not so fast as we would like to. Not all workloads are good for Kubernetes yet. And like we have still some fair share of databases in the data center, but our goal to migrate everything till the end of next year, like to the clouds. Like
So
it's a slow process, unfortunately, because like it used to be a monolith, and like all attempts to split the monolith did not succeeded yet, and probably some of these applications and databases will be migrated as it is. Some others probably will be cut into pieces, like, but it's a long process.
yeah, I remember seeing a video with you. I think it was at the Percona Live, and you were talking about that very problem where it was like, hey, we need 10 or we use 10 terabytes a year or something like that, and we only have 500 gigs left, and so we need to migrate or we need to figure something out fast because we only have about 3 months before shit really hits the fan. So I'll link to that. Whoever wants to check it out, it's a great talk from you. But getting into the idea of operators a bit more, I'm wondering, when do you feel an operator is needed? Like, when should the average company or person implement an operator? Should it be done right from the beginning, or is it when you start having these pains that you were speaking of earlier?
Well, so if you like, it all depends on business requirements. Like there are different requirements on availability, on like uh, recovery time, on data loss window, and so on. And like in some cases, if you just have a single database and you can afford the downtime, maybe like I don't know, in case of an incident up to 30 minutes, you don't even need high availability, you don't need operator, you need nothing. Like you just need to have a DBA, maybe just a consultant which will deploy this cluster and from time to time like do some maintenance. Like in case if you already have a dozen of clusters, maybe like you still can do it manually. Like it depends on how good is your hardware, how often it fails. Like, but if you start start dealing with dozens of clusters or hundreds, you definitely need like very high level of automation. And yeah, this is where operator like is very handy. Like maybe for 10 databases on Kubernetes, operator is already a good thing. uh, for someone, maybe even like a single cluster is already would be a good fit for operator, because you don't need to know quite a lot of details about Postgres. Like operator already encapsulates this knowledge into itself. Like if not operators, then there is some hidden knowledge in Spilo and like or in Patroni. Like for example, Patroni knows how to deal with PG rewind, like
Hmm.
because like when your primary failed, it might happen that it already committed something to the write-ahead log, but these transactions, for example, haven't been reported to the client. But at the same time, these transactions didn't reach the replica, which was promoted. Like
Mm.
Patroni, like can help to resolve such issue, because rebuilding like multi-terabyte database from scratch, it's a like takes a lot of time, it takes a lot of effort. Like
S-
it all depends. Like just for me, like without operator, it wouldn't be very hard to manage. Like if you 100 deployments, but right now, like most of configuration management, like some fine tuning, could be done by developers. Like they have
Mhm.
all control on it.
Yeah, great to know. So I've got a question from Mike here in the chat, and he's
Mhm.
asking if at Zalando you have databases that span across clouds and data centers. And if you do, what kind of challenges have you had with that?
Well, so we use only AWS as a cloud. We don't have like anything on Google or on Azure. Like
Okay.
in some cases, we have databases running just in our data center, and we have replicas running on AWS. But the challenge is that it's not always possible to get direct connections from the cloud to to data center. Therefore, like for Postgres, we rely on write-ahead logs, like on log archiving, on log shipping. Basically, in the data center, we configured archive command to ship logs to S3, and cluster which is running on AWS pulls write-ahead logs from S3 and replace. And depending on how many transactions and how much write-ahead log is generated, the replication lag you could be like of different time. Like for clusters which we run, it's usually like not more than 10 seconds. And like due to the nature, like due to the requirements of from such replicas, it's absolutely fine because like those are used for analytics.
Hmm. So this is another good one that I was actually going to ask, and Mike is kind of echoing it, but he's wondering what kind of shortcomings you see in the operators and in the Zalando operators that we're talking about right now. That is, and what enhancements would you like to see as we move forward?
Well, so there are already quite a few interesting pull requests from external people. Specifically, one of them is implementing uh, like let's say smart restart of Patroni and Postgres. Like right now, operator, like when you change configuration, that does everything very dummy. It like if you, for example, change work mem, like it's a like configuration parameter in Postgres which doesn't require restart, but operator like still when applies this parameter, it starts terminating pods, and this is very annoying. Although, like like on production, people don't change or don't play with parameters so often, but it is still annoying. And we had this issue. We knew about this issue. We had like it in the backlog, but luckily there is one guy working for Cybertech volunteers to implement it. And like how it will look like, operator will call Patroni API, please update workmem, and Patroni will do everything like what is required. It will update Postgres configuration and reload Postgres. That's it. And like there are of course some exceptions where restart is required. For example, when you decide to change shared buffers or when you change max connections. In this case, restart of Postgres required. But again, you don't need to kill the pod for that. But operator is still doing it. And yeah, so like it would be a very nice improvement, in my opinion.
Awesome. So now moving on into like these I want to talk a little bit about replicas because I know you were mentioning that earlier and this high availability. But before we get into that, I want to finish off this thread on the operator itself
Mhm.
and like do you feel like these operators that you've been working with, especially Patroni, they are easily customizable, or is it something that you need to have deep knowledge in them and you need to study it for a few days before you can go and make it your own?
Well, yeah, s- it's again like let's say like operators Spilo Patroni, like maybe like not Patroni but definitely operator and Spilo are a little bit opinionated. Like that's the way how we usually run stuff. Like on AWS we rely on instance metadata to get temporary credential and like in order to access like S3 storage, for example. And like if you don't run on AWS, you but you want to use S3 compatible storage, you need to provide some special like environment variables. And it's sort of documented, but probably not very easy to find. And I think people spend sometimes quite a bit of a time finding this information or figuring out how to do. But from another side, I know examples that people maintain their own like fork of Spilo image because they want to have very specific extensions, or maybe they want to have not Volley and Volgy as backup tool, but like the quite popular and advanced pgback rest, and like people also fork Spilo and maintain their fork like by changing some stuff. And there is even more extreme example. I know that Timescale DB also using Zalando operator, but they built their own Docker image from scratch. Like it, of course, it relies on Patroni, but like except Patroni, like there is nothing from Spilo. Uh,
So I went out and I sourced a few questions from your friends and workmates. And one person that I asked about what they would want to ask you or what they wanted me to ask you was Sandor Swix. I think you know him.
mhm, yeah.
And he asked me to ask you how you handle rolling cluster updates.
Oh, yeah. So there are, in my opinion, there are two different rolling upgrades. Like one when we need to change the Docker image of like of Spilo because we want to, I don't know, upgrade Patroni version or do like minor upgrade of the Postgres. Uh, since uh, Docker image supposed to be like so yeah, immutable. You are not supposed to like exec and like run up get update and so on. Basically, the only strategy you like prepare the new image and you need to do rolling upgrade. So operator also solves this problem. Like it knows that there are 3 pods in the cluster, 2 replicas, 1 master. So it starts with one of the replicas. It updates stateful set and terminates the pod which running the replica. The operator waits until replica will become healthy and start streaming from the master and terminate the second replica. And the same procedure, it will wait until it again starts streaming from the master. And the next step, it's there is Patroni involved. Postgres operator calls Patroni API and asking for a switchover. So like Patroni will gracefully shut down the master, like to ensure that no transactions are lost, like and to minimize the downtime. And one of the replicas also managed by Patroni will promote to the master. And as the last step, we are terminating remaining pod, which was former master. But another problem, it's a rolling upgrade of Kubernetes itself. Like I think I don't remember exactly how often like new releases of Kubernetes happening, but the unfortunate thing that like with new release you have to rotate worker nodes on the Kubernetes, and it means that like you need to basically terminate all pods on such nodes. Like for stateless applications, it's not generally not an issue. You run multiple copies, and basically you will start receiving traffic to other pods on new instances. But like for stateful, it's a big problem. And what operator does, it listens for state of nodes on Kubernetes, and if it notices that this specific node is scheduled to be like decommissioned or restarted or something like this, and operator also knows that on this specific node we have a master pod running. So like what operator does in such case, it does a switchover, like in order to ensure that like on this node there will be no master running and it will be unaffected. But the tricky thing is that replica also could be running on the node which is supposed to be decommissioned. You see where it's going? Yeah, so like, and operator also knows this fact, and therefore operator first terminates the replica on the node which to be decommissioned, wait until this replica resurrect on the node which was already upgraded, and only after that it does a switchover. Basically, this way we can like nearly 100% guarantee that during such rolling upgrade, there will be just a single switchover. So like we want to minimize amount of interruptions for applications like which work in this database.
And since you're talking about replication, is there a wrong way to approach replication in order to know what to avoid, or is it just a question of trade-offs?
Replication. Well, I don't know, like if it's ever possible to get it totally wrong. Like definitely not with Patroni. Well, but like if we talk about Postgres, like there are two different replication mechanisms. One is a physical replication where you literally replicate everything on the block level. Like when you change the tuple, the tuple is stored on the page, and this page or like just a fraction of this page via replication protocol is transmitted to the replica, and replica recreates this like tuple recreates this page exactly in the same format as on the master, like bit by bit, like byte by byte, like page by page. So it's absolutely identical at the end. And the second replication mechanism, it's a logical replication, where you actually stream not physical data but logical data. Like you know that there was a new tuple inserted into specific table, and you while logical replication you get just the tuple, and it allows to like build a lot of interesting stuff, like change data capture. Like you can, for example, push such changes to Kafka, and like yeah, you can do a lot of amazing things. But
So
like for high availability, like only physical replication is a good choice, I would say, because like while logical replication does not replicate DDL, it doesn't replicate information about users, about like databases, like a lot of stuff is missing in the logical replication.
Okay. And since you sorry to mention, but since you mentioned high availability, just if you could possibly give us a very short summary of the talk that you gave about how not to screw up when building a high availability cluster. We'll put the link later on so that people can watch the full talk. But if you could give us just like a short summary of the key points that are mentioned there.
Well, short summary, like first of all, you have to define for yourself with the help of like business people whether you need it or not. Like because like if you can afford downtime, like half an hour, maybe 1 hour, like you can live fine without high availability. But like I probably repeating myself, I already uh, told my thoughts about this topic a little bit earlier. Like the second, what you should think about that you need to distribute your hardware across different failure domains. Like in case if you have multiple data centers, you need to probably have master and replica distributed across data centers. Like another point, like if you want to build something quickly, like homegrown solution with the help of, I don't know, ping command or like maybe something smarter, like you running script on the replica which checks whether the master node is alive. Unfortunately, like there are two outcomes, like either master node is dead or maybe something wrong with the network. And since like possibilities of both scenarios are nearly equal, I would say. It's not just possible to build something by checking the state of your cluster from a single point. First of all, it's a single point of failure, and the second that you cannot really like solve the network partitioning problem. Therefore, like you need to use something like Raft, Zap, or Paxos algorithms. Basically, like they solve the network partitioning problem for you. Like maybe you can try to implement something on your own, but like most likely you will fail.
Hmm.
That's why Patroni relying on well battle tested HCD.
Yeah, yeah, fascinating stuff. So continuing along that HA theme, I know we had Ren Lee on here a month or so ago, and she was talking about how to balance HA with cost. And you touched on it a bit. I think it's really important what you said is talk with business people, see if you can have some downtime. But do you have other ideas on how to really look at the cost of this whole HA, and how do we decide what is important and what isn't?
Well, so HA topic usually also doesn't go alone. Like it goes very close with disaster recovery and like backup. Basically, it all depends on how much data you can lose and what is your maximum recovery time. Like with Postgres, you can get let's say zero data loss if you run synchronous replica. At the same time, there might be different scenario when somebody connects to the database and by mistake drops the table or truncates the table. In this case, you need to recover from the backup. Like backup could be like quite huge, like let's say a few terabytes. But again, Postgres has some mechanisms which allow it to run the delayed replica. Basically, replica, which is like for purpose configured to lag behind the primary by a very specific amount of time. Let's say 1 hour, maybe like 6 hours. Instead of restoring from the backup, you can like reconfigure such a delayed replica to stop exactly at the moment when the truncation, like or where data loss happened. Uh, and here where the price comes, like if you want to minimize recovery time, like you need to pay for such a delayed replica. Like maybe you can use it for analytics, like therefore you will save a little bit, but yeah, something like this. And if we are talking about synchronous replication, because we want to ensure that no, like when you do transactions, the transaction is committed not only on the master, that it reached at least one of the replicas. Such option in Postgres exists, but like there is always performance penalty, like because you need to wait until this transaction is sent to the replica and until replica replies that okay, so I received it, I saved it to disk and applied, and that means that your hardware will be not performing as fast as without synchronous replication. This is also some sort of a price for high availability. And uh, another dimension of such, like I am not sure like whether it's possible to reach it to count it in money, or like if it's possible to get very small downtime with Patroni, probably not. But sometimes there are requirements of having really like zero downtime. Like Postgres is a single master system, and with Patroni, like you can promote replica within like 20 or 30 seconds, like depending on how you configure it. But it's not really possible to get smaller than this 20 seconds. And during 20 seconds, you will have unavailability. And sometimes people come in and asking, like we can't afford like downtime at all. Like this 20 seconds is not acceptable for us. Like in this case, Patroni will not help. Like there are some, let's say, commercial solutions, maybe not for Postgres, maybe for Postgres, but something like BDR with its own pros and cons. But like it costs money. So like
Yeah.
if you want to have zero downtime, you will pay for it, and you probably will pay for it a lot. Like
Yeah.
if you want to minimize recovery time, like you probably also have to pay something. Yeah, that's
So I've got a question here from Brian, and I'm not sure if it's just him trolling me or us, or if it's a genuine question. He's asking, why do people use Oracle?
oh, I'm not an Oracle person, so
Yeah, I think it
probably
might have.
like back old days, there were not so many competitors, and when I first started with Postgres in 2001, it didn't even had write-ahead log. So of course, like the only possible replication was like, let's say, logical replication, but implemented with third-party tools, uh, and we didn't even use it back then. But Oracle already had everything, and it was quite advanced. Uh, but nowadays, I know the opinion of one person who actually invented the Patroni guy, like label for me. Like he tells, sometimes, maybe not even sometimes, but uh, it's often cheaper to develop missing feature for Postgres than pay for Oracle support. So I don't know, like
Wow.
it's very often that people use Oracle because they have like a contract, or maybe they legally are
Licensing,
obliged,
yeah.
but something like this. But like personally, no, I would never choose Oracle for new projects or for existing projects, and I would always encourage people to migrate. Like Postgres is a great database with a lot of features, and in 99% of cases, it will work just fine.
In the case of Zalando, and because earlier you were mentioning the importance of having a business case and keeping the business mentality in mind. Correct me if I'm wrong on the numbers, right? From what I understand, Zalando has over 145 million orders, 4 billion site visits, and I think about 31 million customers. And that was from, I think, from 2019. So I imagine this year even more. How big do you need to have your to? How big does it need to be for you to get to the point where you need to have that conversation and say, you know what, I think we need a database as a service?
Uh, Again, with database as a service, it's a tricky topic. Like you can just get it from AWS, from Google, like from like nearly every cloud vendor, and a lot of like small companies and startups also providing database as a service. That's not something what like you really need to go to the management and like tell that we need to have it. But uh, the other side of such commercial solutions, that it's you usually you easily get in, but it's very tricky to get out.
Mm.
Yeah, like when we run everything on our own, like we can migrate like whatever data where we want to, and nobody is holding us. Uh, some time ago on RDS, it wasn't even possible to have outbound replication. Like they still don't allow to replicate like physically, but logical replication is possible. So this is already something. But for us, uh, yeah, like since we run quite a lot of different workloads, like hundreds of clusters, like if everything is unified, where we can install the tools we use to, and which actually help to investigate problems faster than like with other tools, like it pays off, I believe. Uh, but since Postgres operator, which we built already there, like everybody can use it, and you basically don't even need probably to explain to a management that I want to run some like internal database as a service. It's already open. It's under permissive license. Just take it and
Mm.
use it.
Take it and have fun with it.
Yeah,
So,
but like of course you are responsible for stuff you run, and probably I should also tell that unfortunately I don't like when people try to use GitHub issues as a channel of support for their own like very little problems. It's like flying the huge airplane. You have fully automatic like autopilot. You just turn it on and it's flying itself. But in case if something goes wrong, you good you better know how to fly manually. And in case if you go to a Postgres topic, still need you still better understand how physical replication work, how to configure it manually, where to look for errors, like where is the Postgres error log, like or Postgres logs, something like this. Like it's a yeah, there are always benefits and there are always some cons.
Mm. Yeah, that's a great point. Now, let's talk a bit. I have a question from Evan in the chat, and he was wondering, and forgive my ignorance on this if I don't know what it means, but he's wondering, where does the operator end and the role of the DBA begin?
Well, so basically, operator only helps to orchestrate stuff like user management, like creation of databases, role and upgrade, like or configuration management of the Postgres. But operator, of course, will not check uh, your workload. It will not check like whether your indexes are bloated and you need to reindex or repack them. It will not check PgStat statements and will not find the like badly written queries or misbehaving queries, something like this. So like you still need DBA. Like just a single missing index can ruin completely your deployment. Like let's say I've seen cases with very small database, just like 100 megs, and like it uses 100% of available CPU on the node, and yeah, like nobody understands why. You like as a DBA, you check like the query plan is explained, and you find okay, so there is a missing index. You create this very little index and everything starts flying. Like operator, of course, will not do it for you. Yeah. So like another thing, like it's not very common in the cloud, but because usually cloud vendors, like in case of some hardware is misbehaving, will like stop it, terminate. Maybe they will send in advance the email to you, like please do something because we're gonna terminate the specific instance. But like if you run on premises, you better check like log of hardware errors. Maybe your disk starts failing. Like again, operator or like other tools, non-monitoring tools will not do it for you. It's not their responsibilities, I think.
Yeah, yeah, that's interesting points there. So I think I've got one last question. It seems like we're running down on time. And I wanted to ask if these operators that we've been talking about from Zalando, if they handle the failover automatically and promote the I know some people don't like it if you say slave to the master, um, or do you use so yeah, let's just stick with that for now. Does the operator
Yeah.
handle the failover automatically?
So yeah, I will explain. No, that's not operator who handles the failover. It's a Patroni. Basically, once you deployed the cluster, you can even shut down operator for maintenance or like for whatever reason. But automatic failover will continue to work. It's a Patroni responsibility, and Patroni is running on every pod where Postgres and Spilo are running. And in case of primary failed, like master or primary, that's what terms are used in Postgres world. Then one of the replica will notice that there is no primary, and they will start leader race, and one of them will take it over and promote to the master.
Awesome, man.
Yeah.
This
So
has been great. This is super exciting.
yeah,
I'm
and actually, I know that like Patroni is used for high availability for not only by Zalando Postgres operator. There is a Zalando, there is a Postgres operator from Crunchy,
Yep.
Like it also last year I think started using Patroni for high availability, but before that they have used their own solution. And there is also Postgres operator from Ongres, I think, yeah. And
I think I don't know all the details, but I know we had Rick Vasquez on here a few weeks ago, and he was talking about the Percona operator is going to also be using some of these from Zalando. And so it's
yeah,
definitely
it's totally possible. I know that Percona also like promoting Patroni and using Patroni for high availability. Therefore, I don't see any single reason why they shouldn't use it for Kubernetes.
Yeah, and it's definitely a solid operator and system that you have set up. I am very thankful to be able to talk with you, Mr. Patroni
Me
himself.
too.
Thank you.
Me too.
Thank you
Absolutely.
very much.
I want to thank everybody that is still here with us. And if you are not in our Slack channel, I will throw a link in the chat right now, or you can find it just going to our DoK.community website and clicking on Slack. And that is a place where we talk about all of this stuff on a daily basis. We're trying to get it moving, get more people interested in it, because I know that doing data on Kubernetes is not as easy as we would like it to be yet. And so we are trying to mature it and make it evolve by talking about it, by discussing problems that we're having. So I'll throw that in the chat right now in case anyone wants to check it out. There is a whole channel that is on that is all about operators. So hopefully you will enjoy that if you like the this chat that we just had. And let me just make sure that I get it right. All right. And there you go. So feel free to join. I will see everybody later. Thank you for staying with us. And thank you again, Alexander. This is awesome.
Thank you. Have a nice evening
You
or
do the
day.
same. Thanks a lot.